In this video, I'm going to show you how you can train a UNet model for segmenting epithelium in stroma. So if I go back in my Jupyter environment, I can go to local, UNet, and I'm going to open training now that the data set for epithelium and stroma is ready, what we did in the previous video. So it's always organized the same way. So first we load everything we need to run the notebook. And then we're going to define training. So I'm going to directly change this and define 4 different set of parameters. As for image classification, I'm going to try different values for the learning rate. So a training directory, that's epithelium and stroma training. Validation directory, it's going to be in epithelium and stroma validation. And the output directory, it's in models. We have 2 channels, DAPI and cytokeratin. We said that we would use an imaging field of 512 by 512. And I'm going to try a learning rate of, first of all, 1 for 100 epochs. No limitation, we'll try that later on. And so this is not used. We could increase the batch size. I won't do it just to make sure that it's going to run on our GPUs. It would be faster. Sometimes it improves a little bit the accuracy as well. But we'll stick with it. All right, so this doesn't change. Epithelium and stroma training. Stroma validation. Model. 2 channels. 512 by 512, and this time I'm going to set it up to 0.01 for the learning rate. All right. Epithelium and stroma validation. By 512, I'm going to keep learning rate at 1 e minus 4. Epithelium and stroma training. Epithelium and stroma validation. Model. The channels 512 by 512. And e minus 6. All right. And now I can start the training. So I'm going to just speed up video so you don't have to wait for the entire training. All right, it's done. So now we can have a look at the curves for accuracy and loss with TensorBoard. Sometimes things like this happens. So if something like this happens, you can either change the port or just remove it and change it to So that also happens most of the time with TensorBoard. No, here it works fine. All right, so everything is working fine. I'm going to just remove it and start with the one with very high learning rate of 1. As you can see, for the training curves, but the orange curves, the accuracy and the loss are just not converging at all. And when we look at the validation, for example, for both accuracy and loss, they're flat. And so for accuracy, this means that you always have the same score. When you get something like this, most of the time when you do pixel classification, it means that all the pixels are classified within the same class. For example, they're all background. And that's why it doesn't change at all. And it's just because you're not converging. So let's have a look at the results with a learn rate of 0.01. Now we see that it's much better. So the training is in dark red, the validation is in cyan. So we see that the training is converging. When we look at the accuracy, it goes from a low value to a high value, the high value around 0.93. Validation is diverging at the beginning and then plateauing. So it's not that bad. We still have a difference between those 2 values, meaning that we are probably overfitting here. And by the way, you also have the time, so it shows you that it took about 7 minutes and 35 seconds to train your model. So I'm going to remove first curves because I'm not interested now that just flat. I'm going to look at the one with E minus 4 for the learning rate. So validation in green is again diverging at the beginning, but then is going back and to a value which is extremely close to what we get for training. So it's definitely better in the sense that it's not overfitting now. It looks like very good results. And if we look at E minus 8 now, we see that the training is in gray and the validation is in orange. So surprisingly, the validation is much better than the training, but I would be careful with that. Mainly the training compared to the other values for learning rates definitely shows you that your should increase value of a learning rate.